All right. Nice. Back at it again. Leetcode week 2. Yeah. Let's see. So last time we did this, we solved some arrays, 2-pointer, sliding window. Yeah. So I think today, I'm gonna continue with the other topics. So we're gonna do valid parentheses, binary search, and 3 linked list, I think. So that'll give us 5 questions, I think. Let's see. Okay, let's just close all of these. Okay, so 1 stack, 1 binary, and 3 linked list, hopefully. Let's just do it like that, yeah. So I'll just type in chat so I remember. So gonna have, what was it? Oh yeah, valid parentheses, binary search, and 3 linked lists. Nice. Ugh. I think I roughly remember the stack problem. I think, yeah, valid parentheses. I did this relatively recently. It was one of the questions that I got for my internship, so I vividly remember it. Alright, let's go. Alright. So the question asks, given a string S containing just the characters, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. That makes sense. Every closed bracket has a corresponding open bracket of the same type. Alright, cool. Alright, nice. So if we have this, then that's a valid parentheses. This is also valid, but this is not, because it's not matched. Alright, so that makes sense. The thing is, I kind of like remember exactly how to code this, so I guess I'll just go from that. So the first thing we need actually is a stack, and this stack is basically, I think, gonna contain all like pending brackets, I guess, because you can say that like an open bracket is basically like a, what do you call it, a task that needs to be completed, I guess you can say, and it gets completed once close parentheses is come. So what we can say is that we only want to append open brackets because that's the only thing that we're really concerned about. And what else do we say? We basically say that we remove from stack once we find a matching close bracket. Yeah, I think that's valid. So alright, cool. So then we go for bracket in S, basically. What else? What do we say? Let's just say close bracket. Close is basically a dictionary, maybe? I don't know, is that? Because the thing is, it's like, how do we know what each value type is, right? I guess we can say, how can we do this? So, okay. We'll just say brackets is a type of dictionary. So we'll just have this points to this closing bracket. Yeah. And then we'll just repeat that for everything else as well. This points to this closing bracket. Nice. And then we have this square bracket points to this other square bracket. So I think that should work. For bracket in S, we basically say that yeah, I think that would make sense. Yeah, for bracket in S. So we basically want to append the stack if we have an open bracket. Okay, yeah. So basically what we want to do now is that if we're able to get something with our bracket, right? So if dot get, yeah, forgot about that. So if we say, okay, let's get something with our current bracket, that means it's already implied that it's an open bracket, and that's fine, right? So if bracket dot get that, then basically we just say stack dot append. Yeah, we just append that bracket to the stack. Nice. Else, what do we want to do? Basically, if we know we're not able to get anything from our brackets, we know that it's a closing bracket. So what we want to do is we want to say stack we'll just say current is equal to stack dot pop, basically get the last element, and then we want to say if bracket is equal to our brackets dot get current. So basically we get the matching one. If they're equal, then yeah, that's fine. Or we can just say yeah. So we'll just say if it's not equal, then we'll just return false. Yeah, like that. And then just basically return stack equal empty, because by the end of it, it should be empty, I think. Let's try run it and see what happens. I think that is it really, but I don't know. Brackets is not defined. Did I spell it wrong? Yeah. God damn it. Alright, brackets. There you go. Yeah, okay, cool. Hopefully that works. Okay, nice. Well, it actually worked. That's good, I guess. So yeah, let's just try to analyze it real quick. So I guess we have like this, we have two arrays. So in terms of memory, this will be for the stack, this will be O of S, where S is the length of the string. And then we're basically just looping through the string once, so the runtime will be O of S. So this will have runtime O of S with memory O of S plus I guess O of 3, but that's constant memory, so I think that just goes to O of S. Oh yeah, O of S for memory and O of S for runtime. I think that's the most efficient we can get it, because the thing is we always have to loop through the entire string to see if it's valid. So I think that's okay, but we'll see. Let's see how we fare overall. I think this is a pretty pop from an empty list. Okay. Oh, okay, yeah. Right, I forgot that, because it could be the case that you start with an empty with the closing bracket, so we want to make sure that that is the case. So we just want to say if there is a stack, then we just pop that. Else, I guess we can just return false maybe, because the thing is, if like, I think so anyway. Yeah, because this is supposed to return false, and our stack would be equal empty anyway. So we'll just try to submit that. Hopefully that works, or is there some other cases that I'm not considering? Okay, cool. Yeah, so it generally beats like an alright amount, I think. But let's see like what the top answers are like. Okay, so you have close to open, so it's kind of like the same thing. For C in string, if C in close to open, Yes. So basically that's saying that if it is a closing, if it's a closing string, I think. Okay. Yeah, I think like, yeah, the sort of like general algorithm here is kind of just the same thing as the one that I just wrote, but I think like the syntax may have it like have a better runtime, I think. But yeah, I think overall like the general idea is pretty much the same because you're just looping and you're basically appending to the stack. Uh, let's see. Yeah, yeah, okay. But I guess like a better way to kind of do it is to just do all of the comparisons in one place, because like I have like a nested comparison here, so maybe I could just have it in line, maybe, I don't know. But I think I'm pretty happy with it, you know, because I remember roughly how the algorithm works, and it's not like a bad runtime, so I think that's okay. All right. That was pretty quick. But yeah, that's valid parentheses done. Now for binary search. I think I also remember this one mainly because it was like one of those solutions that's like really interesting. So we have an array of numbers which is sorted, and an integer target. Write a function to search target in nums. If target exists, return its index, otherwise return -1. You must write an algorithm in O of log of n. So we did also learn about this in university, which was pretty cool. So yeah, it's like a pretty fresh algorithm in my mind. But the main idea here is basically to take advantage of the fact that it's sorted. So yeah. Yeah, generally it is quite interesting. So we'll just basically, I guess we could use a recursion maybe, I don't know. So we'll just say middle is equal to the 0 plus nums length of nums -1 divided by 2. I think that's the general idea here, because we basically want to take it smack down middle, right? So yeah. Alright. And then after that, we basically say that if wait, yeah, okay, so if nums at m equal to the target, then we just basically return m. Alright, cool. But this thing, all integer and nums are unique, that's fine. I think otherwise return -1. Okay, yeah. So we also have to take into account that it may not be found, so that's fine. Yeah. Okay, cool. Else if, basically we're just gonna say that if it's more than it, then we do something else. Delta m is larger than target, and basically yeah, I guess we'll just return the search for so return search. Yeah, I think that's fine. Okay, so I think like for this thing I'm just gonna make use of recursion just because I think it's a bit easier maybe. So we'll just return the search from m onwards. I think that is the syntax for it, I'm not sure. Then we'll just pass down the target here, and then do the same thing for if it's less. So return nums m less than target, and then just return the search m by everything previous up to m, and then target. So yeah. Okay, now we have to add like a case for when it's yeah, for when we're gonna return -1. So if nums at m is not equal to target and length of nums basically just 1, you just want to return -1. I think that's it actually. Yeah, because like the idea here basically is just you take the middle. If it's more or less, then you adjust the array accordingly. I think that's it, and then you just have that base case to return -1 in case. Okay, there's an error somewhere. What's the error here? Unexpected indent. Why? Maybe we just divide 2 only, maybe? Is that the issue? Surely not. Okay, yeah. What's the indent issue here? If nums m is equal to target, then we return m, which makes sense. Okay, yeah, this is quite interesting actually. Yeah, I don't actually know like why this is an issue. If okay, wait, let's just double check this. What's up here? If nums m equal target line for a solution, what is the indent issue? God damn. Okay, are we? Is it because of this slash? Could it be? Surely not. Is it? No, definitely not, right? Okay. Maybe that slash was important, I don't know. Now you just get an indent issue. Yeah. Bro, what? Okay. Nums m equal target return m. Okay, yeah. Wait, what's happening here? I'm so confused. What's the indent? Alright. This is really jarring actually. Okay, wait. This target isn't in, right? So like what's the issue here? Return m. Not like, you know, right? I have no idea. I guess I'm just not gonna use the thing. I'll just go for while true, basically. Basically just don't use recursion, just cause like some issues with it. Okay. So we start off with okay. How's this gonna work then? So if nums, okay, yeah, that's fine. So then that's there, and then we'll just say m is equal to m. Ugh. Wait, why is this so difficult for no reason? Just some stupid indenting here, but I don't even know why. Okay, so the issue now is that we have to somehow modify this m value to take the middle, but I don't know how to do that. So if m is equal to the thing divided by half, then basically say, yeah, this is actually quite interesting. Okay. No, this now thing was supposed to work. I don't know why it's not working though. That's exactly what I wanted to do. Okay, let's just try run it, see what happens. Bro, what the hell? Okay. Alright. Try to see what happens there. This is so annoying for no reason. Okay. Just get rid of that. Yeah. Alright. Run that hopefully. And now the line is just there. Unexpected indent, like why, dude? Let's just try divide just one slash instead. Maybe that's the issue. Nope. Because we are supposed to return M, but I don't know, man. Like, what's happening here? I just don't get it. Oh, this is so confusing. Okay, wait. Dude, this is kind of peak, you know? Dude, it's just like some syntax issue. I'm just gonna see what's up. Because I don't get why there's some syntax issue. Oh, I think self.search maybe. Is that the reason? If that's the reason, I don't know what to say, man. Nope, that's not the reason at all. Huh. Oh, alright. This is so annoying. Just why though? Like, what is the issue? I don't get it. Because the indentation of function calls. What? Alright. Run it again. I didn't change anything, but you know what? That's fine. Yeah, I don't get it, bro. What's happening? Nums and target, yeah, that's all it takes. Well, why is it? Maybe. Bro, what is this? I'm just so baffled right now. Okay, at least it's an index out of range this time. Let's just see what M is. For some reason, it's out of bounds. Alright, let's see what's the issue here. I think this logic here should have been fine. But that's fine. 2, 0, and then -1. Alright. This is for the first test case. 0, 1, 2. Yeah, this is the first test case. And then target 9, so that should have been here. Thanks, Nums. Maybe I just need to take out this -1, maybe. And then that should be okay. Nah, I don't think so. Yeah. So 3 and then 1. 0, 1, 2, 3. 5, and then it goes from there to there. It passes for test case 2, but did I get this the wrong way around? That's quite funny. I don't think so, but okay. You know the C++ solution? Yeah, I mean the thing is, it's like it's quite a common question, but I just can't, like, I don't know, dude. Start equals 0. You mean like what? The M or something? Or is that something else? Never mind. But yeah, no, I think I'm getting close. Because like the first thing it selects is 5, but it's going left ways. So I think I just need to reverse the logic here. But yeah, never mind. So if your middle is greater than your target, then yeah, then you need to go left. I just need to reverse this logic, then it should be fine, I think. And then that should be good. And I don't need to print this. Hopefully that's all good. Let's see what happens. Nope. Amazing. Why is it even outputting 1? That's like very peculiar. So our target in this case was 9. Oh, right, because... okay, yeah, that is an issue. It's not preserving memory. Oh, wait. Yeah, that is an issue. Because M is only relative to like the current thing, so we can't use well, we could use recursion, but start equals 0 and n equals lost index. So yeah, I don't know, I was just trying to think of like a recursive solution, because I think it is like you could definitely use like a normal loop, but I don't know. I think, I don't know, like, because like the issue, the thing is it's working, it's just that it's not able to remember what the indexes are. So maybe I'll just not use recursion, maybe. I don't know though. Alright. What is diff? Okay. Like I got it here because I definitely couldn't find it. But how do we preserve the current M? Yeah. I mean, yeah, I guess the only way is to really just use the for loop. Because like you couldn't, like you can pass in nums and your target, but unless, no, because even, yeah, I was just thinking that maybe you can just use the array to pass in back like what the, just try the while loop. Yeah, I guess so. Yeah, I was hoping to use recursion, but I guess it's not really like, I don't know. I don't know how you would preserve like the memory of the indexes if you did. Okay. So while true, basically we're just saying that that's our M. For now, that's like bang on middle. Actually, let's just say our L is equal to 0. And R is equal to like of nums. And let's just say, hey Adam, what's up? Welcome back to the stream. I am struggling because I have no idea how to do this. Okay, L plus R, nice, divided by 2. That is your M. That should be it. And then basically, if length equals 1, then that's fine. If nums M equals target, that's fine. Nums M is less than target, then we basically want to say that L is equal to M. If nums M is less than the target, so that means we want to increase, yeah. And then in this case, we want to decrease, so we just say R is equal to M. I think that's it, I don't know, but we'll see what happens. And then this one just computes the middle of the two each iteration. And that should be it. Maybe. Please. God damn it. Invalid syntax. Oh yeah, I wasn't supposed to do that. Return R equals M and L equals M. That doesn't work. So that should be fine. Because all I'm saying realistically is just modify our left and right pointers according to the values. So maybe that's okay. Come on, please. 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 This is taking quite a while actually. Time limit exceeded. No. God damn it. Wait, why though? Oh wait, I forgot to break. God damn. Alright. Return M and then break maybe? I don't know. I think. Yeah, I think so. Because once you just return that, then you also want to break. That's quite interesting how return doesn't actually break it immediately, I think. Or we can just say about res equals 0 or -1 maybe, and then we just say that this and then break. And then we'll just say here res equals M and then break. Then return res. Yep. Maybe. Come on. This looks like a time limit exceeds. Yeah. But why though? Wait. Am I missing something here? Wait, what am I missing here? I'm so confused. Because isn't this true already? Like, we can just break out of it. M is the middle of the left and right pointers. And then that's your condition is wrong. Which condition? This one? Surely not. Wait, what? I'm so confused. Wait. Because I'm just saying if length of nums is... Oh, wait, yeah, you're right. Right, because this never actually gets executed. Yeah. That's actually true, yeah. We can basically say if R equal to L, maybe? Then break, because in that case, then the 2 pointers would be there. But I thought this changes what left and right does too. Because you don't want to change R if you... Right? Am I wrong? I don't know. Like... Because yeah, the first condition was definitely wrong. Expected a colon. Yes, thank you. Alright. Because this should automatically change our left and middle and our right to the middle pointer. Middle value, whatever it was. Okay, I mean, judging by the time, it's definitely wrong, but wait, what? Okay, can I just print them? I don't know. That means like the actual conditions isn't being met currently. Could be that Python does it that way. I don't know. Wait, let's see. Let's just see what M is for each iteration. Because if M doesn't actually get updated, then just look at the solution and move on. Nah. It's not even been like 30 minutes. I just usually take around 30 minutes. Because the thing is, I know that how the algorithm works in general. It's just that I just don't. I have trouble implementing it. So it's more of like a... I don't know. But yeah. It's taking a while as well now. But that's fine. Nah, surely I'm forgetting something. So it's 3 4 3 1 2 1 2 1 1. That is odd. I wasn't expecting that. So the first index was 3 and then it was 4, which is correct. So 0 1 2 3, and then it says 4 is the next index, but it should have broken in that case if nums M is equal to target, which is nums of 4. Yeah. That's really weird. Okay. Print nums m instead. Nah, cause that's weird. Cause basically it did get the index of 4, which is where 9 is, but then it doesn't do anything. But it should have like executed here. Should have broke out of this loop. But it's not for some reason. But why? If nums m is equal to the target, then rest is equal to m and then break. Yeah, that should have worked. That's very confusing. Yeah, legitimately right here it found 9. What? Maybe I just need to make this an elif, maybe? That's not right, but... Alright, last run, and if it doesn't work, then I'll check the solution. Alright. Solution it is. Alright. I did solve this previously, I think. But yeah. Too bad. Bonus one-liner. That's fine. I don't need one-lines. Okay. So this person did it sort of the same as I did. So you have your middle. While L is less than R, basically, current is nummits, return mid. Yeah, it's basically just the same algorithm, but why is it different though? Maybe because I'm not updating M, but M gets updated each iteration. Bye. Alright, bye, dude. Yeah, this is weird. Huh. Alright. Let's see. Nah, this is proper weird though, cause like, surely my thing was right anyway, but never mind. Alright, let's just rewrite this thing. We don't need -1, so let's just say turn -1 there. While L is less than R, basically we just want to keep appending it. So yeah, so M is basically L plus R divided by 2. Okay. Then current is equal to nums and M. If current is equal to target, that is definitely how you spell it. Alright, if current is equal to target, then we just want to return M. Else, if current, no, that's not how you do it. If current is less than target, what do you want to do? Basically, if the current is less than the target, it's more than the target, then we want to change it. But how do we change it? Current is more than the target, then we basically bring down R, so R is basically equal to the mid. He does it, yeah, wait, yeah, R is equal to mid, that's what he does. Oh, but he has an interesting condition here. If O plus equal 1, maybe that's like the issue I had previously. Maybe, let's see. current is less than target, then we just say L is equal to M. Yeah, okay. Maybe. Let's index out of range. Current is equal to noms is M. Maybe I was supposed to put these in actual brackets. Alright. Maybe. Yes, time limit exceeds. So it's basically whatever this logic here is that is important. That is quite interesting though. So if low equals mid, alright. But they perform this calculation first. That is quite interesting. So just like that, and then if R is equal to M, basically R plus equal 1. I kind of get it, but at the same time I don't understand why it is like that. If L is equal to M this time, so L minus equal 1. Yeah. If this passes, that'll be quite interesting. Local variable M reference before assignment. Alright, yeah. I guess we have to just do it here first, right? Oof. What is this? That shouldn't worked. What the hell? Alright. Dude, this is really weird. What if we just copy this whole thing? If this works, I don't know what to say, man. What? What? I basically had the same logic. This is really weird. I is equal to the length of numbers. Yeah, that's exactly what I had previously. Yeah, R is equal to length of numbers. Low is 0. L is 0. Calculate that thing. Yeah. Could it be because like I had two L if statements? That be the case? Because that's really odd. Surely not, right? What? You know what? Yeah, forget this. Forget this question. I'll just mark it as done for now, but I'll come back to it later. Yeah, because that's really odd. Like, yeah. Never mind. Next one. Oh, reverse linked list. Oh yeah, I don't know about this one, you know. I don't really know that much about linked lists, but I kind of get the general idea. Given the head of a singly linked list, reverse the list and return the reversed list. Do we have to do this in place? Surely not, right? Linked list can be reversed. Can you implement both? So we have the head. So that's the implementation. You have the value as well as the next. How will we reverse this? So default next is equal to none. I guess we can just say previous equal to none. And then for node in, oh wait, yeah. We'll just basically say while head dot next. Yeah. Head dot let's say current is equal to head. Then while current dot next. Then so while we have a next value for the current, you basically say that the current dot no wait, what is this? I'm so confused. Okay, so we basically say that when we're at the start of the node, right? So if it has another one, I want to basically say that, okay, change this to the previous one, the next value to none, and then say go to here and then change it back that way and then that way and so on. So while we have current dot next, our current dot next, so then we say, ooh, this is interesting. Okay, wait. So we'll just say that our head is equal to current dot next. So then basically it points to 2. And then we'll say current dot value is equal to, no, we don't want to change the value, but we want to say that current dot next is equal to previous. Nah, that's not how it works, surely. Oh, wait. This is really confusing. Okay, wait. While current dot next. Okay, yeah. So we basically, because we want to preserve the value, right? We want to say that the current dot next is equal to previous, but at the same time we want to say current is equal current dot next. Yeah, so that's fine. Then we basically say current is equal to head. Maybe, yeah. So that it just saves it there, and then we'll just say previous is equal to current dot value. Yeah. Wait, is it? Then we'll just like that. So the current one is equal to the head, and then after that, head is equal to the current dot next, and then current dot next is gonna equal to the previous for this current node, and then we'll just say current is equal to the head, which is the next node. So let's just go through this. So basically first we start at current is equal to 1. And then since it has a next one, what we basically say is our head is going to be this 2 node. And our current one here, the next one is going to be equal to none. And then after that we set our current dot head to be current thing to be here. And our previous to be, oh wait, yeah. So we got to preserve that. So but how do we change it? Because I want to say that this current dot next one is equal to none first before changing it to the current value. So how do I do that? So I think, because we have head equals current next, right? So then That's okay. Wait, this. Okay, wait. So then current is equal to this one. If we have a next one, we basically want to say, all right, head is gonna be this one. What? Oh. Alright, let's just... I have no idea what's going on, but I'm just gonna return current. Let's see what happens. There's definitely like some logic. List node. Oh wait, what? It's a list of nodes. That doesn't make sense. Wait, what? Because list node has no attribute value, but it literally says, oh right, not value, val. Okay, that's good to know. I think it's like this, but I forgot. I had a task needing to reverse a list once and made it, so I get the current size and then go through the list. Save the last in a head variable and then set the first as next from the previous and break. The connection to one before the last. What? I'm not gonna lie, dude. You just made it a lot more difficult. Non-type object has no attribute next, so I think it's because it reaches the next thing, I think. Yeah. Wait. No, what is this? Alright, okay. Let's see. I had a task. So get the current size, but we don't have the size of it, I don't think. And then go through the list, save the last in a head variable, and then set the first as next. Last as the head. That makes sense. Like, I get what you mean. Is it like working backwards in a way? But the thing is like to do that we would have to loop through the whole thing and then like loop through it again, but in reverse in a way, no? But I don't know. Because what I'm trying to do is like change it as I go along. I think, yeah, so basically while we have a current on next, we say that head is current on next. Let's just say 5 there in a head variable. Yeah, but how do you access 5 from 1? Because we're basically starting at node 1, right? It's not like a length type of thing. I think maybe it's like this. So we just say next node is basically current on next. And then for this current dot next, that's gonna be equal to none. And then our current is gonna be equal to next node. Then previous is equal to current dot val. Then set 4 is next from 4, etc. 5. And set 5 is next from 4. Now, yeah, I get what you mean, but what I'm saying is that, like, in order to get to 5 in the first place, you have to start from 1. So you have to, like, to access that node variable. So we would have to kind of, like, go towards the end and then work backwards to reverse the whole thing. But I think you can reverse it as you go along the list. So, yeah. Maybe. Right, because we also need to do and current. Maybe, I don't know. Non-type has no attribute next. Yeah. Okay. Sorry, dude. Like, I'm just, yeah. It's also hard to kind of understand like purely logical through like that kind of like text. get like a sample code you can show me, then I think it'll be easier for me to get it. Wrong answer. Okay, that's good to know. So we only got the output 5. Nice. Current dot value. Current is equal to next. I think I'm getting closer. So our current one is at the head, while we have a current and current is next. So next node is equal to current dot next. Then we say current dot next is equal to previous. Then previous is equal to current dot value. Current is equal to next node. So like it's not setting up the next thing properly for some reason. Previous is equal to current dot value. Is that not how you do it? Maybe we can just print what previous is equal to. Let's see what happens. So none, 1, 2, 3. Okay, that's kind of good. Alright. Is this right? I don't know. Okay, wait. Alright, I thought that would have worked, but never mind. Current dot next equals previous. That definitely doesn't work. What? Come on, think. So while there is a current and current dot next, basically say, okay, here's our next node, which is current dot next. Then we say that our current node dot next is equal to the previous one, and previous is equal to the current dot value, and then current is equal to the next node, and then current dot next is now equal to previous. Yeah, that should have worked. Oh, but previous is a number. Is it? Yeah, previous is a number, that's why it didn't work. So it's not supposed to be dot values, it's supposed to be equal to current. Yeah, I think so. Let's see it. Please. Wrong answer. Nice, but yeah, definitely amazing. Alright. Alright. Current dot next is equal to previous. Bro, fuck. Okay, wait. Come on. Think. So essentially while our current node exists and there's a next value for it. Yes. Yep. Okay. Then we basically say grab the next node with current dot next. And for our current node, current dot next now is equal to previous. And now previous is equal to the current node. right? Yeah. Then our current one is equal to the next node. Oh, all right. I think so, but yeah. I feel like I'm like along the right tracks, but I just can't seem to like piece it together. Let's just print what the current dot next is. Okay. God damn. All right. Let's print out our current one. Yeah, it's quite literally just that. Yeah, I'm not sure honestly. I'm like proper lost now. Because I feel like the logic makes sense, but I mean, evidently not, right? But I don't know. Because previous is equal to none. That's just like a general thing. Let's just try print what previous goes up to. Because now they're not values anymore, they're actual nodes. So first it's none, which makes sense. And then list node value 1 with next of none. Then previous one is 2, next is value 1 with next none. Yeah, this all works. So yeah. Ah, that's really odd. Because you can clearly see that it is reversing it. Like 3 points next to 2, which points next to 1. But for some reason... Maybe I just need to return previous, you know? I don't think I do, but who knows? Let's see it. 4, 3, 2, 1. So it's missing 5 now. That's interesting. Maybe all I need to do is just cur dot next equals previous, and then return cur. Maybe. But then the okay. Does it work? I think it should work. Current dot next is equal to previous, and then just return current. Non-type object has no attribute next. That's interesting, because I thought okay. Oh, okay, wait, what? What's happening? Okay. While current and current dot next. Our next node is equal to current dot next. Then current dot next is equal to previous. Is it because there's like some... Is there like some issue with like naming and like not creating copies? Because I feel like that might be the case. Previous is equal to current. Yeah, I don't know, man. I don't know. Whoa. Our current is equal to next, and you know what? No, I can't give up, surely. Because returning current gives you a 5, right? Alright. Dude, I feel like I'm so close, but I just can't seem to put it there. It's like it's stopping too quickly, I think. So how do I... Maybe while current on next, maybe. While current, maybe? So, and current on next. Now I get an empty. That's amazing. But then, I just need to return previous. And then that works. Maybe? I don't know. Hey, let's go. You know, the funny thing is, like, it works, but I don't actually know why. Because the idea I had in my head was that previous is just gonna be like a place to replace the current node with the previous thing, and it's not actually gonna contain the final result. But you know, if it works, it works, you know. Let's see, hopefully this thing actually works. Alright. At least it runs. I don't know what else to say, really. Alright, so this is my solution from Leetcode, I think. So previous and current is none and head. So next equals to current dot next. Okay. And current dot next is equal to the previous one. That makes sense. Previous is equal to the current, which makes sense. And current is equal to next. So I think it's just in terms of like the order of which I'm doing the certain things. But yeah, I mean, I think I definitely understand like what's happening, but it's so confusing because like you have to avoid like creating references instead of like values. So you have your current one, which is your head, and your previous one, which is none. So you're at a current thing, you just basically store a temporary for current.next. So let's say it's 2 and we're at 1. And then we basically say the one's next is previous, which is none. Say previous is equal to the 1 node, and then we say that the 1 node is now 2. And then that just continues. Yeah, that makes sense. I think I definitely understand better now that I've actually tried to code it from using my last brain cell. Alright, merge 2 sorted list. Let's go. This is definitely gonna be a bit more interesting. I don't know if I'll be able to do this, you know. Alright. Okay. Merging 2 sorted lists. You're given 2 heads of 2 sorted linked lists, list 1 and list 2. Merge the 2 lists in a 1 sorted list. The list should be made by splicing together the nodes of the first 2 lists. Return the head of the merged linked list. Alright. Okay. Yeah, that makes sense. Hey, let's go. Alright. Cool. So let's just say... Yeah. So how do I create a result? Alright. Let's just say result is a new list node. Or do we want to create a new one? Yeah, probably, right? Yeah, you need to avoid like overriding things. Yes, yeah. Okay, cool. So we'll just create a new list node, I think. But I don't want a zero value though. Or is that alright? Damn, I don't know actually. Wait, wait. Result is equal to the list node. Yeah. Wait, how do I do this again? So basically, I mean, I guess like the idea here is pretty simple. You just basically say, alright, we're at this one and this one. If this is, or if this is less than this or equal, then append that to the result. Then append this, and then move this one forward, append that to the result. And this one is not less, put that down. This moves here, put that down. Then put this down, then put that down. So that's how it works. It's easier said than done, obviously. But yeah, I don't know how to get the done part now, so yeah. Okay. Okay. Let's just say, let's just start with to establish like one. If list one dot value is less than, if it's less than list two dot value, right? No, but we want to do it in a loop. Wait, but how do I like, how do I create a new one? In a one sorted list, this list should be made by splicing together the nodes of the first two lists. Okay. Because I want to like create, I don't want to create a new node because then that would basically have value of 0. So I don't want that, so that's why. But how would I do it without creating one? Because then I would have to just extract the first node. So I guess I can just make that comparison here maybe. So if list1.value is less than list2.value, then we want to basically say our head is equal to list1, else head equals list2. So then while list1 and list2, all we want to say is, so now we have our head variable. Then we just want to do this. Dot next is equal to list1, and this one dot next is equal to list2. Basically, I think that makes sense. If list1.val is less than that, then list2. Okay, yeah. So if this one is less than this one, so let's say if it was 1 and 3, then we want to do that. And then we want to say list1 is equal to list1.next. Yeah. And then list2 is equal to list2.next. So, but then there could be a case where list1 and list2 finish. So then if not list1, no. So then we'll just say if list1, then we want to say head.next is equal to list1, else if list2, then we just say head.next equals to list2. So this is in the case that if, let's say, this only had like one node, so like imagine that 2 and 4 doesn't exist, so it would be 1 gets appended, 1 gets appended here, but now this exits this while loop condition because now this one is not a non-type. So then list 1 doesn't exist, so this doesn't get executed, but list 2 still does, so then we just append everything from list 2 onwards. So it would be like 1 1 3 4 basically. Nice. And then we just basically return it, and boom. Hopefully this works. I don't know. Come on, please. If I get this first time, that would be crazy. Please, please. Ah, this looks like a time limit exceeded, you know? God damn. But why though? That's what I want to know. It's probably definitely in this bit here. While list 1 and list 2, so then head.next is equal to that, and then list 1 is equal to... Yeah, that should have worked. Let's see what's up here. Head equal list 1. Oh, maybe I need to change this as well. So list 1 is equal to list 1 dot next. And then this one as well. Let's do dot list. No, that's definitely what I wanted to do. List 2 dot next. And then I think this should work. Come on. Come on. Let's go. Come on. Please, please. Non-type attribute value. Alright, yeah. Because it could be the case that... Yeah, it could be the case that... Wait, yeah, alright. Because it could be like an empty one, right? For one of the tests. If list 1 and list 2 and... Yeah, we'll just say it's like that. Then if... Then push this in. So basically, if they both exist, then we want to go into that loop. Else, if... not list 2, so like list 1 doesn't exist, then we just return list 1. Same thing for list 1. There's definitely a better syntax to do this, right? Surely, but I wouldn't know it, so let's just try to run that, see what happens. Unmatched. Nice. Okay. Let's see that. Expected a comma. Yes, thank you. Comma. I meant colon. Semicolon, please. Yeah, hopefully that does it. We got 1-4. Alright. Why? That is interesting, but you know. Okay, let's just print what the head is here. So the one here is basically 1. So 1 3 4. Okay, so yeah. Yeah. Yes. Okay. Made the binary search with recursion. Nice. You have like a link to it that I can see? Or like you can just type in chat and then I'll just see what it is. But yeah, I think the issue with my one, I think, was just I didn't get the syntax down right, because I kept getting like indentation errors, and that was like really stupid. But you know, we move. Yeah. So I think I actually need to construct the actual list here. Like I can't use an exit. Actually, I could. Let's just see. Okay, I'll make one nice. I look forward to it. So head.next is equal to okay, let's just print out what the head is after this thing. Please. I'm definitely not as smart as I was promised, but I feel smart being here. Welcome to the chat anyways, Duddles. I think, well, don't worry about that, because I have no idea what's even happening. Been at this problem for like, what, 10, like 20 minutes or something. It's actually ridiculous, and I'm so like, I don't know, man. I don't like messing around with data structures. But, you know, it has to be done. That's the whole point of this session. Yeah, for some reason, all the work is, like, being undone here. Maybe if... I think, like, if it's in here, then it's fine. But for some reason, the moment you exit the loop, it gets unwritten. Let's run it. Come on, please. Please. Yeah, you can see like here it says this node is 1, next one is 1, but then it keeps doing that. Oh, okay. Yep. Got it. Nice. So head equals head.next. Ah, I'm so stupid. I had to like do that for each one. Now this is how it's done. Watch this. All test cases pass now. God damn it. Fuck. YouTube didn't like that link. Oh, okay. I mean, I think you can just copy paste the actual code in, I think. Because, like, I think it should be fine. I think, like, default, it just removes any links or something like that. I don't know. But yeah, I think if you copy paste the text, I think it should be fine. Okay, so why is this wrong? Ah, you're kidding me. Oh, okay. I think I know what's up. Okay, yeah, I get it. Leetcode problem binary search. How do I, like... Is that an actual link? Because I don't see any HTTPS. Oh well. Try like copy the actual link. I don't know. Because that's like not a link, I don't think. Did you solve it in Kotlin? Why does it say it's solved in Kotlin? That's quite interesting. Alright. Yeah. Okay, yeah, totally get it. And then I just need to return res here. It's like the head keeps getting updated, so I can't return that because then it'll just be the final node. So I need to like save the current state as that current head, and then hopefully that should work now. Yes, he's done it. All right, let's submit, and hopefully that works. Please, yes. I'm victorious today, guys. I've actually done it. Let's see my previous solutions. Yeah, these ones were a lot faster. They look better as well. My solution looks so long. In Kotlin, that's quite interesting. You like do iOS development because that's quite interesting. I only know how to do web development, as you can tell from my channel. But yeah. I have dabbled in like mobile development previously, but that's when I had like no idea how to actually code. So it wasn't really anything cool. Alright, let's see the top solution. What were they on? Let's see. Okay, come on. Wait, what? Is this it? Because I can't see it. Okay, no data. Nice. Okay, merge two lists. So head equals to list node with 0. Pointer is equal to the head. Okay, that makes sense. While list 1 and list 2, if list dot 1 value pointer dot next equal list 1 is equal to that. Yeah, this is exactly what I did, I think, in terms of the first logic, but they used a head with list node and then returned the next value instead of doing the initial comparison. That's interesting that it's quicker. I mean, I guess that makes sense, but yeah, that's cool. Yeah, because I think this bit here definitely like messes it up. I do my backends in Kotlin because JVM is pretty powerful from the stuff Netflix added to me. Oh, interesting. Backends in Kotlin, you know, that's interesting. Yeah, I've wanted to learn Java for like web development, like because I know some companies they still use Java Spring for their backend systems, so I definitely want to learn it in the future. Yeah, I also might make a video on it, but we'll see. I was supposed to record a video today, but I was like I felt sick, so I didn't really get around doing it, but I'll definitely like record one soon enough. But we'll see. Oh. Alright. Cool, that's that one done. And now we're on our final question for today. Nice. Yeah. I can't wait to go on to all these different stuff. I don't know if I want to do necessarily all the easy questions, because I feel like something like bit manipulation won't really come up, and it's all like mostly easy. I think I'll go till maybe, I don't know. Maybe I might go to greedy, all the way till greedy's. Yeah, okay, so greedy doesn't even have any easy problems. Neither does dynamic programming. So yeah, I think I'll do all the easy ones until dynamic programming and then move on to the medium questions. Get well soon. Thank you. I think like I'm getting better, but you know, we'll see. I think it's just hay fever, but that's alright. Is it even hay fever if it's already summer? Who knows? Linked list cycle. I think I remember this one as well. I learned Java for now at school and I know a little bit of Python. Yeah, Java is very like commonly taught in school. I think it's because you learn like object oriented first, and Java is like 100% object oriented, so you like apply that straight away. So yeah, I think that's like an interesting like pattern that a lot of schools have, is that they always teach Java. I think Python is like also another thing, because like the syntax is very human readable, so they love teaching that as well. But yeah, Java. I'm guessing you're using Java for object oriented, am I right? Or Haskell in school? Really? That's interesting. Alright, because like I learned Haskell in my first year of uni, and like nobody knew what it was, so it's interesting that they're teaching that in like high school, unless you're also in uni, or unless you go to the same uni as I do, so that would be kind of wild. But yeah, no. All right, linked list cycle. Given head. The head of a linked list determine if the linked list has a cycle in it. There's a cycle in linked list if there is some node in the list that can reach again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tails next parameter index. Oh, pause. Okay. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that toss is not okay. Alright, interesting. Okay. 320 -4 pause 1. Okay, yeah. Okay. Okay, so I remember this is a question of like rabbit and hare or something. You basically have one pointer at the start and then one pointer that's like 2 nodes ahead, and then continuously do one step. But I forgot how. Okay, yeah. No, I'm in high school. We need to do it since it's on the learning plan of our state. Okay, fair enough. So this one's actually quite interesting. So we basically have a visited dictionary. Mainly because this is how you can easily check for visited nodes. So we'll say that L is equal to head and right is equal to head dot next. I can't remember why, but there was definitely a reason why you like go twice in a row. I think it's because it's able to catch up or something. I forgot, but there's a reason why you go twice. But yeah. So then while L and R, so while they both exist, while they're both non types, visited dot append. Is it append? No, it's not. Surely not. Actually, I can use a set, and I think it's add for sets. So then just add L. Okay, yeah. If R in visited, then basically return true, I think, because there is a cycle. Yep. And then visited dot add L. Okay. L equals to L dot next. R is equal to R dot next. So then that's fine, and then otherwise you return false. Because either the what do you call it? It's either the it's either the thing has a loop, or if it doesn't, R basically becomes null. Something like that. So then you can just return false here. But obviously there's an error that if it's like one node here, this throws an error straight away. So, you know, that's not exactly ideal. But like this one would work here because L would be this one, and then R would be next, which would be 1, and then yeah. If R dot value is then visited, L dot value, I just want to say that, and then we just say visited dot add L dot value. All right, cool. So then while left and right, then if R dot value and visited return true, visited dot add the L value, then just move on that. But if it's 1, then we just basically say return false. Yeah, return false, because 1 can never have a loop. Yeah, can it? Actually, it might do. I don't know, actually. We'll just say it doesn't. Oh wait, but it's not a length, is it? We'll just say if head.next is equal to itself, then we'll just return false. Which makes sense, I guess. So let's try to run it. See if that works as an initial solution. Cannot assign to attribute here, maybe, man. Oh yeah, right, of course. Thank you for that. None type. Okay, yeah, that makes sense. Because if it's I think in some cases it wouldn't work. Hit dot next dot next. Does that not work? I thought 2 because it points to 1 that would work. What? I kind of get that though, but yeah. Because we need to be able to... Alright, this is actually quite interesting. L is equal to the current node, and R is equal to the current node, but 2 nodes ahead. So... that should have worked. I'm not sure why that's not working. Okay. Any of you guys have an idea? I'm actually kind of interested. Because we definitely don't want to access if it's like a none type, right? Let's say if there's only 2 nodes, then that would, and no loop, that would return a false. So how do I like overcome that? Oh shit, dude. Okay, wait. Okay, yeah. Got it. So if head dot next dot next, then we basically say that we just say this. Else we just basically say return false as well. Because if there is only 2 nodes, it's impossible for it to have a loop unless there's like 2 nodes ahead. So therefore that should work, and hopefully this should be correct, please. Let's see it. Nope. Okay, wait, why? Bro, this actually kind of sucks. Okay, wait. Let's just try print it, see what happens. If hit dot next dot next. But surely this isn't null, right? Actually, I should have just printed the head. Error found cycle in the list node. Interesting. Okay, let's just print the head. But yeah, I think this should have worked. I'm not sure why it's not working. Value 1 next none. Oh, okay. Oh, right, okay. Let's just say none. I guess that's it. But this also still stays true, because it could be the case that you have like only 2 nodes with no cycles, and that would have thrown an error. So if hit dot next, but if there's 1 and that loops to itself, is that considered a cycle? I guess so, right? But then that should catch it automatically, I think. Alright, cool. That actually worked. I'm actually like super shocked. I didn't expect it to be this quick. If hit dot next equals, then that's a false. Alright, cool. Can I make this more optimized though? I don't know. Because like this is needed, because in case like we need to, you know, check for the 2 node issue thing. But yeah, no, I think that's it. Really? I don't know. Yeah. Because you either keep looping until you find that cycle, or it just ends. Nah, I think it's gonna break at some test case that's not here. Let's see. Yeah. None-type has no... Oh, okay, basically if it's just... if hit is none. Alright, cool. Alright. Let's see it. None-type object. Alright, I have to put that first. That is really strange, because like the order of your conditionals actually matter. I always found that to be quite interesting, because surely if it doesn't apply, then it just, you know, sits there. I think you can use hashing. It would be O of n. No, but surely isn't set like also O of n, because querying a set is also constant time, I think. I mean, I don't know, but because I did want to create a dictionary at first, but I thought that would be kind of odd. That's a very specific test case. I'm not gonna try that. I'll do your error thing though, but yeah, I think it's relatively the same. Visitor equals to this, and then let's just say I think you can. Okay, yeah. Not sure. That's fine. Okay, wait. Because I actually forgot how to add keys. Let me just check. Add keys in dictionary. Alright. Yeah, it's just like that. But how do I dynamically do it? I guess maybe it's just quite literally like that, maybe. And then just what? Visited dot value. Yeah, I think that should be fine for the dictionary bit. I think object has no attribute val. Oh wait, not visited value. I meant hid dot value. Wait, did I mean that? I think so. Wait. Is it? No wait, what did I mean? No, I meant L, I think. L dot value. Yes, I think so. Wait. Okay, if head equals null, then return false. Visited is this. L is equal to head. If head dot nice, then R is equal to that. Return false. L dot value is okay, yeah. While L and R, if visited dot get R dot value visited dot. Don't want that. Alright. I think that should be good, but it was failing a test case just now, so I think there's like some error logic. So let's try find that. Okay, so okay. Let's just try submit again. Maybe somehow that fixed it. I don't know. Yeah, so there's that error there. So let's see. Oh wait, no, that's not how you do it. Yeah, okay. So I think like the error I had was that I was comparing it to the visited thing, but then there could be an issue where that isn't really the case. So it could be like, yeah, so I think what I should do instead is to have it increment by 2 instead of just incrementing it by 1, I think. Because right now, like, what do you call it? Right now, only the right node, it just increments by 1 each time. So we don't really want this visited, like, thing anymore. So that's okay. So then, instead what we say is that if it's equal to it, so r dot next, so that it always goes by 2, and then if r dot val is equal to l dot val, then we basically return true. Because basically, like, imagine if it's like 3, 2, 0, -4, and 2. So like this would, so first starting would be 3, and then the next one is at 0. Then in the next step, this would be at 2. And the next one will also be at 2. Because it doesn't increment by 1, it increments by 2. So then because they're equal and they're at the same point, then that's now 0. Same thing here, both are at 1. Well, because they are all on the same node, then that is also gonna be an error. I mean, not an error, but it'll return false because it's both visited. So yeah, that should be okay, I think. I think like there's just something that if you just increment by 1, it's not including that. Yeah, but I guess there is that issue as well. Yeah, okay. But surely, like, how do we increment it without it like being overwritten? I mean, not overwritten, but I mean like so that it doesn't have this none type issue. Because if there's a cycle, then it's fine because it's gonna go on infinitely. But how do we catch that it's what do you call it? How do you catch it such that the next one is fine? While left, and I guess maybe you can just do next here. Maybe, because evidently if the right to path is gonna be a none, then that means there is no loop, right? I think. I don't know. Maybe. Come on, please. Nope. Okay, yeah. So that's fine. We can just leave it as like this, and then that should be okay. So while our fun. Okay, wait. So none type object has no attributes next. So I guess you can just say R and also that, right? So while it's also valid, I guess you could say. Damn it, okay. That's really interesting. Oh, because you can have the same value. I didn't know that actually. Okay. I guess you can say if R and L is equal, I think. Because I mean, I don't know if like from an object standpoint that would work, but I'm just trying to say like if you just compare it like surface level and not like instance. Maybe, I don't know. Hey, let's go. Thank God. Nice, that's cool. He solved it in Python. Yeah, sorry, I didn't read that, but yeah. Sucks in memory. Yeah, mine just sucks in memory and runtime, so. I don't know. I think it's like, I don't know, man. Let's see like what I did last time. So we had just 2. Oh, okay. While f and f dot next, s is equal to f, s dot next, f is equal to f dot next. If s equals f. That looks so much better. I don't know why I didn't think of that. That's quite interesting. But surely you don't need to have like 2 head pointers, right? You can just do it on one. So you don't care about the s, but you only care about f. That makes sense. While f and f dot next, if s equal f, then return true. That's interesting. Let's see what the ultimate runtime would be. But overall, everyone used the logic of I'll only be 16% in memory. I mean, hey, bro, it's still something, man. Alright. Yeah, I don't know, when people start using like utils and stuff, that's like really odd. But yeah, let's just see a different one because people want to try to get like the most efficient runtime. Alright, brother. Hey, Arnav, what's up, man? Welcome to the stream. Just trying to solve some Leetcode stuff. What? I was doing, for context, we were working on the, what was it? Finding a cycle in linked list. Yeah, that's actually the last question of today, so you came in at, like, when the stream's about to end, basically. But, you know, now I'm just, like, trying to see what the optimal solution would be. So, if head equals none, or head.next equals none, then return false. That makes sense. Slow equals head, fast equals head.next. Really? Okay. That's interesting. Wait, let's see. Wait, so I just copy and paste this in my browser? How does that work? It doesn't have like HTTPS. Is it this? I can't tell. You only basically... Yeah, you just link the solution. I mean, you just link the question. I didn't get the solution. That's okay. It is what it is, man. Alright, so if head equals none or head.next equals none, return false. Slow equals head, fast equals head.next. While slow is not equal to fast, if fast equals to none or fast.next equals none, return false. Interesting. Okay, so his one is... That's interesting because some people start from like... His one starts like 1 ahead, but it increments by 2. I guess the idea is that like it doesn't matter which part of the linked list you're in. If you're just incrementing by 2, it'll like catch up anyway if there's a cycle. Yeah, definitely quite interesting. I think I'll just rewrite my solution just to get a better runtime. Your YouTube summarizer and Twitter video really kickstarted me to learn the API stuff. Yeah, let's go. I'm glad it motivated you, dude. I think like, yeah, I think like working with APIs is like super interesting because then that's when you actually understand like how you're able to get this sort of data. Yeah, and there's like a lot of like fun APIs online, I think. I think for me, a lot of my like ideas comes from dev resources. This basically has like a list of free APIs and stuff. Yeah, here. This is basically where I get some of the ideas. I've never used one from here, but it's definitely like it gives me an idea of what like stuff to use. But yeah, it's definitely interesting, so you should go check it out. I'll put the link in chat actually, so you can check it out. But yeah, definitely something worth like going for. Yeah, there's a lot of interesting stuff. And I have like one like video that I'm gonna make and hopefully publish by this week, but we'll see. Because I have like my internship, so I don't know how well that's gonna go, but you know, we move. But yeah, I'm just gonna rewrite my current thing just to make it simpler. Right. Yeah, it is pretty cool because it's like I think most of them are free. I'm not sure, but you know, you can definitely check it out. See what happens. Okay, so if head equals none or head unless, okay, then return false. Let's see. L equals head. R equals head. So then while L not equal to R. No, wait, no. I guess, yeah, you could just do next. Yeah, so while L is not equal to R, basically what we want to say... No, wait, no, that's not true. If L equals R, then we want to return true. And then basically we'll say like if R equals to none. Is it? I know. And r dot next. Then we just return false. Else basically. L is equal to head dot next. R is equal to head dot next dot next. I think that's it. I don't know. But yeah, let's see it. Let's see it. I think that should be good. I can't remember though. But yeah. Nope, that's not the one. Let's look back at the solution. Definitely time limit exceed, yeah. Submissions. Then let's go for this one here. Okay, if fos equals none or fos equals, okay. Let's run that. Hopefully, false expected true. Wait, what? I feel like I have the exact same code for these two. Let's see. Okay. While slow not equal to fast. If r is equal to none. If r equals to none or fos dot next equals to none, return false. Okay, cool. Now let's run. Hopefully this works. It should work. Then we can just submit that and then end the stream on a good note. Nope, this thing apparently decides it doesn't want to work, but that's fine. Yeah, that's really funny. That is odd. Yeah, it's supposed to work, but it's not. But that's fine. L equals to head, R equals to head dot next, while slow is not equal to fos. If fos is equal to none, or fos dot next equals to none, return false. Slow is equal to X. Yeah, no idea why that's not working, but it's how it is, I guess. Yeah, because like this works, right? This, yeah, but then my one doesn't work, even though it's basically just the same thing. When the time limit is time. It's so weird because like I have the exact same code, it's just that I renamed some of the variables and it's not working straight away. It's actually stupid. Yeah, like what? Okay. Like here, try to find the difference between these two solutions. And let me know. Like, I can't find the difference at all. Or am I just being stupid? Like, what's going on here? Right, I don't know, dude. Like, this is really weird. If R is basically my fos thing, right? Oh wait, you can't. I didn't even notice. Like, it's actually really difficult to see on stream. Yeah, try find the difference. I honestly can't. Never mind. Bro, like legit, there is actually no difference. Like, what? Maybe it's because I have like this. I don't know. Like brackets. Yeah. Oh, okay. Wait, no, never mind. Yeah, I don't know, dude. I don't know. Let's just try run it. See, maybe that works now. I don't know. If it does, I don't know what to say, bro. Python be Pythoning. Yeah. Oh, wait, what? You found it? Please do point it out. Inline 37, 38. 37, 38. Is that not the same? Oh, yeah, dude. Ah, you caught it. Okay, yeah, I was incrementing the head and not the actual pointers. Thank you, thank you. That actually makes so much more sense. Leetcode really shows your true nature. Dude, I'm actually like so blind now. Alright, that should work. Thank you for that. It is actually, when you think about it, like the logic of my previous solution is basically the same as this solution, but because of that minor tweak, it like boosts up like runtime wise like really high. I always find that like really fascinating. It's only 10 milliseconds difference, but you like beat so many more people. It is really like cool. But yeah, I guess that's it for today. Finally can check it off. List cycle. Yeah, cool. So next stream, which should be next Sunday, I will be working on, I guess, all of these tree questions. And then just keep doing that. Yeah, then heap, no backtracking, no graphs, no advanced graphs, and then just that, then dynamic, and then yeah, it is actually super efficient, but I don't know, I think it's just more of like a Python syntax thing, because if you add like more white space, like just enter, or you have more comments, like that significantly reduces your running time, so you have to try to eliminate most of that if you want to pass it. But yeah, this is quite interesting. I'm definitely gonna, yeah, there's not really many easy questions left, so then we'll start going into the normal part. But yeah, I think that's it for this stream, so I'll be ending it, and I'll hopefully be seeing you guys next week for the same thing. Alright, thanks so much for watching, and I'll see you next week for some more Leetcode. Or maybe I'll see you this week. Well, I mean, I won't see you, but I'll hopefully be posting a video maybe Wednesday. I don't know, it depends, because I'm gonna have to like start a new project, but it'll be an interesting project, I promise. And yeah, bye bye, thanks for watching, really appreciate it.